let's take a look at the exercises for the examples for chapter 9. True and false questions. The first one, the margin of error can be reduced by reducing the size of the sample. This is false. A 99% confidence interval has a greater chance of catching the true population mean when compared to a 90% confidence interval. That is true. Multiple choice questions. A what is defined as the probability that the interval estimate will include the population parameter of interest, such as a mean or a proportion. That would be your confidence level. A random sample of 30 business students required an average of 43.4 minutes to complete a statistics exam. The population standard deviation to complete the exam was 8.7 minutes. The margin of error for a 98% confidence interval will be, I'm simply asking for the margin of error. Margin of error is equal to z times sigma over square root of n. How do I know that I have to use a z value instead of a t value? I am given the population standard deviation. Sigma is given, so I know that I'm in case 1. I want to calculate the margin of error. This would be z times sigma over square root of n. I have sigma, I have n. The only thing missing is the z value. To find the z value, I use the confidence interval. 0.98 divided by 2, 0.49. We go to our z table and we try to find a match for the corresponding probability, 0.49. Once again, 0.4900. This is the closest, 0.4901. I'm pretty sure you cannot really see much. I don't know if this helps. Too many numbers. 0.4901 corresponds to 2.33. So the z value will be equal to 2.33. Go back to your formula. 2.33 times sigma, which is 8.7, divided by square root of 30. And this is going to be 3.701. So the correct answer will be D. A random sample of 35 business students, that means n is equal to 35, required an average of 50.7 minutes to complete a statistics exam. That means x bar is equal to 50.7. Assume that the population standard deviation to complete the exam was 10.4. Population standard deviation, this is your sigma. Sigma is equal to 10.4. What is the 95% confidence interval around this sample mean? So, sigma is given. Automatically, I know that I'm in case 1. Case 1, the formula for the confidence interval is x bar plus minus z times sigma over square root of n. So, x bar is 50.7 plus minus, I'm missing the z value. I find the z value from the confidence interval, 0.95 divided by 2, 0.475. 0.475 will give me a z value of 1.96 from the z table. 1.96 times 10.4 divided by square root of 35. So this will be equal to 50.7 plus minus a margin of error of 3.4455. So the confidence interval will be from 47.2545 to 54.1455. Again, you might have slightly different numbers based on the number of decimals that your graphing calculator rounds up to. Based on the answers that I have, the answers that we are given here rounds up to one digit, therefore the correct answer will be A. Now, if you wanted to use your graphing calculator, to find the interval in cases like this, when you're not asked what is the z-value or what is the margin of error, what is the standard of error, if you're simply asked to provide a confidence interval, you can use your graphing calculator to do so for case 1 and case 2. Before I showed you how to do case number 3 with your graphing calculator, and now we'll show you how to do case 1 using your graphing calculator. So you want to go to Stat, Test, and then you scroll down to number 7 where it says z-interval. And again, I'm using z-interval because sigma is given. You want to make sure that you're under Stats, and you plug in sigma 10.4, x bar 50.7, n 35. Confidence level that I'm looking for is 95%. I enter it as a decimal, 0.95, and calculate. And this will be your interval, your confidence interval right here. So that's another way to calculate the confidence interval, a lot faster, definitely. A random sample of 35 business students. Once again, same thing. We have n equal to 35. We have x bar equal to 50.7. We have sigma equal to 10.4. And in this case, I'm simply asking you to calculate the 99% confidence interval. You can use your graphing calculator or you can do it manually. If you were to do it manually, this would be 50.7, your x bar, plus minus the z-value. The z-value that derives from 99%, you can either use 2.57, you can use 2.58, or the average of the two, 2.575. So 2.575 times 10.4 over square root of 35. So 50.7 plus minus 4.5266, this would be a confidence interval from 40, always present the lower limit first, 46.1734 to 55.2266. Your answers are round up to 1 decimal, therefore the correct answer will be D. Steve's average golf score at his local course is 93.6. That means x bar is equal to 93.6 from a random sample of 34. N is equal to 34. Assume that the population standard deviation, this is what I want you to focus, the type of standard deviation that you have. That means sigma is equal to 4.2. The 90% confidence interval around this sample mean will be what? Sigma is given, so we have case 1, x bar plus minus z times sigma over square root of n. Only thing missing once again is your z value. For a 90%, we will do 0.9 divided by 2, 0.45. 0.45 will give me a z score of 1.645. We take the average of the two values because it falls somewhere in the middle. So this will be 93.6 plus minus 1.645 times 4.2 divided by square root of 34. And by doing the calculations, and again, I want you to be careful with your calculations, you will have a confidence interval from 92.4151 to 94.7849, or something really, really close to that, based again on the rounding settings on your graphing calculator. So the correct answer in this case will be D. For number 8, a random sample n equal to 17 hotels in Boston has an average nightly room rate of 165.4. So x bar is equal to 165.4 with a sample standard deviation S equal to 21.7. Construct a 90% confidence interval for this sample mean. Since I am given S, a sample standard deviation, we are case number 2, x bar plus minus t times S over square root of n. X bar is 165.4 plus minus. For the t value, I will look at the t table for 90% and degrees of freedom equal to 16. 17 minus 1. So you will go to your t table, 90%, which is the second column, and you're going to look across for 16 degrees Fahrenheit. So wherever these two values meet, this will be your t value, 1.746. 1.746 times 21.7 divided by square root of 17. If you do your calculations correctly, you will see that the correct answer will be C. Number 9, a random sample of 150 mortgages, that means n is equal to 150, was randomly selected. From this sample, 17 were found to be delinquent on their current payment. So that means x is equal to 17. The approximate standard error of the proportion for this sample is, I'm looking for the standard error of the proportion. The standard error of the proportion will be equal to the square root of PS times 1 minus PS over n. To find PS, I will need to do x over n, which I have, 17 over 150. This is going to be equal to 0.1133. So this will be equal to 0.1133 times 1 minus 0.1133 over 150. If you do your calculations, this will be 0.0259, and again, this will vary based on the decimals that you've used for the PS. The closest answer to that, based on the ones that I have, will be B. A random sample of 150 mortgages, once again, n is equal to 150. We have x equal to 17. I'm looking for the 98% confidence interval for the proportion. This is the case where we will use, to make things easier, the graphing calculator. We will go to Stat, Test, A, x is 17, n is 150. The confidence level that I'm looking for is 0.98, confidence coefficient. This will be your answer right here. So the correct answer is C. Now, let's look at the problems. Tire Kingdom installs automobile tires on a first-come, first-served basis. A random sample of 50 customers experience an average wait time of 93.7. So n is equal to 50, x bar is equal to 93.7. Assume that the standard deviation of total wait time for all customers, that means sigma, 20.7 is 20.7. Determine the margin of error for a 95% confidence interval. Once again, in this chapter, more than any other chapter, it's very important to be able to identify accurately the information given to you in the problem. Since sigma is given, I know that I will have case 1. To find the margin of error, I will take z times sigma over square root of n. To find z, I will do 0.95 divided by 2.475, and then I will check the z table. As we mentioned before, the corresponding z value is 1.96. Therefore, the margin of error will be 5.71. Now, for the same problem, we have n equal to 50, we have x bar 93.7, we have sigma 20.6, we have 20.6, this was 20.6 here too, 20.6. Determine the 99% confidence interval for the sample. Once again, 0.99 divided by 2, 0.495, the corresponding z-value is 2.575. You plug in all the information that you have, everything else is given. Once you find the z-value, things are becoming very, very clear, and you do your calculations. Make sure when you do your calculations that you use your parentheses correctly. So, if we were to use our graphing calculator for this example, let me adjust the light for a minute. We would go to stat, test, 7, z interval. You want to make sure you're under stats. Sigma is 20.6, x bar 93.7, n is 50, and I'm looking for 0.99 confidence interval. Calculate. And you will find the same answer as we did when we did it manually. So for problem 3, suppose a random sample of 52 National Football League players. So once again, this is your N, 52, had an average weight of 252.5. The average weight, this is your X bar. Assume that the standard deviation for weight of all players, that means it's for the whole population, is 31.1 pounds. That means that this is your sigma. Determine the 80% confidence interval for this sample. Once again, sigma is given. We are case 1. The only thing missing from the formula of the confidence interval is your z-value. So the corresponding z-value for a probability of 0.4000 is 1.28. You plug it in your formula, and this will be the confidence interval that you have. Let me try to do this with a graphing calculator as well. Stat, tests, z interval, under stats. So we have sigma equal to 31.1, x bar is equal to 252.5, n is 52, confidence level that I am looking for is 0.8, calculate and enter. And there you have your confidence interval. The two answers might slightly differ because you have to deal, when you do it manually, with the decimals. So, but they will definitely be really, really close in both cases. Number 4, according to Edmunds.com, the average price that the shoppers paid for a new car is $30,320. Assume that the standard deviation for the price shoppers pay is 8,740. This is your sigma. A random sample of 38. This is your N, who purchased a new car, paid an average. This is your X bar. and I'm looking for the 98% confidence interval. Once again, the z-score that corresponds to this confidence interval is 2.33, x bar 32,700 plus minus 2.33 times the standard error of the mean, 8,740, divided by the square root of 38. And the confidence interval is 29,394 to 36,003. Now, we want to test the validity of the claim made by the company. Since the confidence interval does contain the original claim, the value of the original claim, which is 30,320, then we can say that the claim is validated based on the sample that we have. Problem number 5, a random sample of 18 Exxon customers used an average of 16.1 gallons to fill their vehicle with a sample standard deviation of 5.4 gallons. So we have N equal to 18, we have X bar equal to 16.1, sample standard deviation, this is your S, which is equal to 5.4, determine the 90% confidence interval for this sample. So I'm looking for a 90% confidence interval. Now, since S is given, I know that I have case number 2. The formula for case number 2 is X bar plus minus T times S over square root of N. The only thing missing is the T value. To find the T value, we go to 90% confidence interval and degrees of freedom 17. Where do these two meet? This will be your T value, 1.74. You plug it in and you get your answer. If you were to use your graphing calculator for the second case, you will go to Stat, Test, and you will go to number 8, T interval. Enter. You want to make sure that you're under Stats, and you enter the values. X bar 16.1, S is equal to 5.4, N is 18, confidence level 0.9. Calculate and enter. And there you have the two. From 13.886 to 18.314. For the next one, the average grocery bill at the cash register for a random sample of 17 shoppers at a local store is 53.7. This is your N, this is your X bar. Sample standard deviation, this is your S. Determine the 80% confidence interval. Again, the only thing that you're really missing, first of all, we are case number 2 because S is given, is your T value. We find the T value by taking degrees of freedom, which is 16, and confidence interval, which is 80, and we find that the T value is 1.337. You plug in the information, and this is the confidence interval that you should find. Once again, make sure you practice your calculations if you do it manually. Number 7, the number of companies that are fully funding executive MBA programs have been decreased over the past few years. A random sample N of 180 recent graduates found that 32, X is equal to 32, worked for employers who fully funded the program. Determine the 98% confidence interval for this sample. Now, I'm looking for a confidence interval for the proportion. If I were to do it manually, I would have to find first the PS. We find the PS, the sample proportion, by taking X over N, 0.178, and then we find the Z value, as we did in case 1, 0.49 corresponds to a Z value of 2.33, and we plugged in the information in our formula. If we were to use our graphing calculator, we would go to stat, test, letter A, 1 prop z interval. X is 32, N is 180, confidence level 0.98. Calculate and enter. So this would be your answer from 0.1115 to 0.2441. And this concludes the examples for chapter 9.